Good morning. Today we are going to talk about section 5.3, which is inequalities for sides and angles of a triangle. So there's two theorems that are important here. The first one is that if one side of a triangle is longer than another side, then the angle opposite it, which we kind of already talked about in a previous chapter, has to be the longer side. It has a greater measure than the angle opposite the shorter side. So if I'm looking at a triangle and I have 60, 30, 90, 90 is the largest angle. So that side has to be the largest. If this side was 40, 30, 20, okay, this is the largest side, so that means the angle opposite it must be the largest. Okay, so we did already touch on this a little bit. The next theorem basically says, I kind of just explained both of them, but if one angle of another triangle has a greater measure than another angle, then the side opposite the greater angle is longer. Okay, so if this is 40, the angle opposite is the largest. If this is 90, the side opposite is the largest side. Okay, so that's basically what those two angles is summing up for us, and those two theorems, sorry. So putting that into action, if we want to list the angles in order from smallest to largest, if the perimeter, remember that's the total outside of the shape, okay? So if the perimeter is 702, so they gave you two sides here. So I want to take those two sides away from 702 to find this missing side. So I'm going to subtract 330 and 166 from 702, and I get 206. So that makes this side 206 inches. Now that I have all three sides, I can figure out which angles should be the smallest to the largest. So the smallest angle should be across from the smallest side. So the smallest side I have is 166. So the angle across from that is P. So angle P is the smallest. And you always need to pay attention. Do they say smallest to largest or largest to smallest? Pay attention to that. So they said smallest to largest. So I'm starting with my smallest angle. My next smallest side is 206. So I'm going to look opposite it, and the angle's M. So angle M would be next. And then lastly, angle N. List the sides in order from shortest to longest here. So we know that in a triangle, we're missing an angle. And we know that in a triangle, all three angles add to 180. So if I add 42 and 48, I get 90. So that means if I do 180 minus 90, that means this angle here has to be 90 degrees. Okay, so I'm just using my knowledge of the fact that three angles in a triangle add to 180 to find this missing angle. Now I can list the sides in order from shortest to longest. Shortest is first. So for shortest side, I got to look for that smallest angle, which is 42. So the side opposite it should be the shortest. So that side is GF. The next smallest angle is 48, so the side opposite that should be the smallest side, which is GE. And then lastly, I have this side here, which is EF. This next problem is a little beefier. It says to find the value of x and list the sides of triangle CSY. So I'm going to draw CSY in order from shortest to longest if they're giving you a degree measure for each angle. They're giving you an expression for C, S, and Y. If they're giving you all three angles, you should know that all three angles in a triangle add to 180. So I'm just going to take all these expressions, add them together, and set them equal to 180. So I added C, S, and Y right here. 3x plus 20 plus 2x plus 37 plus 4x plus 15, set it equal to 180. Now I'm going to start to solve this so I can find x. Once I find x, I can find these angles, okay? So first I'm going to combine all my x's. I have 3x, 2x, and 4x. That will give me 9x. And then I have 20, 37, and 15, which will give me 72. To finish solving, I'm going to take away 72 from both sides. I get 9x equals 108. And if we divide by 9 here, we would get that x is equal to 12. Now that I know what x equals, I can find all three of these angles. So they said that angle C was 3x plus 20. So I'm going to take this 12 and plug it in. 3 times 12 is 36, plus 20 is 56 degrees. Angle S is 2x plus 37. I'm going to plug that 12 in again. It's 24 plus 37, so angle S is 61 degrees. And then lastly, angle Y is 4x plus 15. I'm going to plug that 12 in. 4 times 12 plus 15 is going to give me 63. Now I have all three angles, so I'm just going to write them on my picture here. So C is 56. Wow, Y is 63. And S is 61. Now, the main question here was find X, list all the sides from shortest to longest. So I still need my final answer. I need to list these sides. So I'm going to put 1, 2, 3. A little small because I'm running out of room here. My sides from shortest to longest, I want to look for that smallest angle, which is 56. The side opposite it is SY. My next smallest angle is 61. Look at the side opposite it, that's CY. And then lastly, the next side was across from the biggest angle, which would be CS. And if you flip that around and say SC, that's fine too, that doesn't matter. Okay, flip your page over if you have a copy at home. Okay, this next problem is a situation where we have connected triangles. So we're going to focus on one triangle at a time at first. So first we're going to focus on triangle FED, which is this one here, this top one. So order the sides from shortest to longest in that top triangle. So I'm going to look for my smallest angle in this top triangle, which is 46. So I look opposite it. That means DE is my shortest side. Okay, so DE would be first. Then the next smallest angle I have is 66. So opposite that is FE. That would be my next smallest side. And then lastly, I have FD. That's the last side. Now they want you to take a look at the other triangle, DEH, over here at the bottom. List these from shortest to longest. So my smallest angle here is 49. So the side opposite it has to be my shortest side. So that's EH. Then my next smallest angle is 51, and I have DE across from that. And then lastly, I have DH is the last side. Find the shortest segment in this entire figure. So they asked you for the shortest segment in this top triangle, this bottom triangle, and now what's the shortest segment in this entire figure? Now, this is a little tricky, but the easy way to look at it is what are our two shortest segments? Our two shortest segments are these two. However, if you look here, DE is used in both triangles, and it's not the smallest in this second triangle. So that means that EH has to be our shortest segment because these are the two shortest in both triangles. This segment is also used in this triangle, and this one is smaller. So EH would have to be the shortest figure. A lot of people make the mistake of looking for the smallest angle. Okay, that's not how it works. You have to be careful with that. You have to remember what we talked about, I think, last unit, where it doesn't matter. Like I could have the same angle. I could have angle 46 and angle 46, but I could have side 26 opposite it and side 56 opposite it in another triangle. The angle doesn't mean that the side has to be a specific amount. Now, the last question here is to find how many segments are longer than FE. So FE is here, okay? The only one that we can prove is longer is FD because of what I just said. We just said that we had just said that it doesn't matter what the degree of the angle is. The sides opposite could change. So we have to say that the only one we can prove is longer is FD. We could assume that DH might be longer, but we can't prove it. So we can definitely say that 1 or 2 are longer, but we can only prove FD is. Okay, the last thing we want to talk about today is the exterior angle inequality theorem, which is the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. So an exterior angle, so remember that looks like this. This would be exterior. These two are your remote interior. Okay, so these two are remote interior. They're not necessarily equal, so I shouldn't label them with the same arc. But if you remember correctly, these two add to equal that outside exterior angle. Okay, that was a rule we used maybe 2 units ago. So what they're saying here is this has to be greater than both of these. That's all. So what measures less than angle 7? Angle 7 is an exterior angle right here. So you just want to name its 2 remote interior angles. Those 2 remote interior angles have to be measured less than it. So you could say angles 4 and 5. They're both those remote interior angles. They have to be less than it. What measures greater than angle 6? So angle 6 is right here. Angle 6 is a remote interior angle with angle 5. Okay. Actually, with angle 4. Because if you look here, if you ignore this, right, this is an exterior angle. These are the 2 remote interiors. Okay. So 4 and 6 would be remote. So you can't say that 4 is greater. You have no proof whether 6 or 4 is greater, but you do know that angle 3 has to be greater because it's that it's that exterior angle. So angle 3 would measure greater. All right, hopefully this was helpful from home. If you have any questions, please reach out. There are office hours and you can always email me. Have a great day.